In this part of the webinar, we are going to talk about hazardous waste and emerging water pollutants. As expected, hazardous waste corresponds to hazardous chemicals that we use. That means that the chemicals that we use or we produce can be found in the environment as well. There are the flammables or ignitables waste, that is waste that can burn very easily. Toxic waste that are hazardous to the human health. Reactive waste that can easily and spontaneously create a blast. Corrosive waste, this means waste that can erode containers as well as the human body. And there are also waste that are hazardous to the aquatic environment, so we don't want to discharge them in our sinks. And also there are radioactive waste that are considered the most hazardous. For example, in the University of Patras, we collect our hazardous waste. We don't throw them into our sinks or into our waste. And we have specialized private companies that pack this waste in a very certain way, and then they ship them to Germany for destruction. As we have already discussed, a wastewater treatment plant is designed to remove dissolved organic load, BOD. It is not designed to remove hazardous waste. So whenever we have a legal discharge of hazardous waste into our sewage, then the hazardous waste pass through the wastewater treatment plant and end up in aquatic systems. Examples of such compounds are surfactants that can be found in detergents. This photo shows wastewater containing surfactants directly discharging into the sea in one of the most famous beaches, found in the most famous island in Greece called Mykonos. Surfactants can be found in detergents, and the problem is that although they are removed in the wastewater treatment, there are still residues that are released into the environment. And for this reason, we can find in drinking waters all over the world some small concentration of such compounds. And although some of them are forbidden in Europe and restricted in other countries, and they have been decreased in the environment, we can still find low concentrations in rivers and sediments. The problem is with the cationic surfactants that they are readily degradable in aerobic conditions, but the metabolites are toxic even at low concentrations. If we apply such compounds into agricultural land, it is possible to destroy the soil ecology. Also, we need to know that one of their metabolites, nonylphenol, is an endocrine disruptor and is not as degradable as the parent material, so it persists in the environment much more. And this results to new forms of environmental pollution that includes pharmaceutical and personal care products, hormones, antibiotics, vitamins, deodorants, surfactants, sunscreen, mosquito repellents, cholesterol, and caffeine. Although these compounds are found at low concentrations, they are designed to affect the organism. So we don't know what happens to a fish that swims in a water that contains caffeine and cholesterol at the same time. In order to decrease the discharge of such compounds, we need to search solutions through green chemistry and try to replace such compounds with environmentally friendlier compounds.